Sound lives out in space and it's in the air around us, but we want to grab it and record it and mess around with it. And so how do we do this? What's the trick? We need to figure out a way to kind of capture it, to capture sound. And that requires converting changes in the air pressure, these acoustic sounds, into electrical voltages. So in order to do this, we need something that's sensitive to these little patterns of vibrations out in the air around us. For humans, we use our ears, but we need a device to get this into a form that we can really work with it. So we need a transducer, we need a microphone. A transducer can take one form of energy and convert it into a different form of energy. A microphone is sensitive to the sound waves, and it's able to convert those into electrical voltages. And once the microphone's converted those sound waves, the electrical voltages that we get can be thought of as analog. Let's take a look at the three different states of sound. There's the acoustic, the analog, and the digital. Now, acoustic are the sound waves, that's the sound out around us. Analog are electrical voltages. These are what run through your guitar cable or hook up your home stereo. And then finally there's the digital state, where information is represented by numerical values, or ones and zeros. It's binary data, or the language of computers. So if these are the three states of sound, what we want to do is be able to get sounds from the first two, from acoustic and analog, into the digital world, so that we can work with digital audio. So there's taking sounds and getting them to the land of digital, and then there's taking those digital sounds and getting them back out into the air around us. And this whole process is referred to A to D conversion, or analog to digital conversion, and digital to analog conversion. Here we can see we want to take the sound out around us, the sound of a snare drum, pick it up with a microphone, which converts it into electrical voltages, and then convert it via our analog to digital converters into numerical values that our computer can work with. Once it's in that digital stage, we can do things like edit it on our computer, add effects. Everything you do when you're working with audio on your computer, we have that sound in that state in digital. Then when we're done making our piece of music or podcast or whatever, we want to get it back out so other people can hear it. So we go the other way to get it back to a speaker of some variety. So we go from digital to analog, which runs it through the speaker cables out to a speaker, and then that speaker generates new acoustic sound and sends our music or our podcast out into the air around us, and we're actually making something that goes out and changes the molecules in the room around us. It's pretty cool, actually, if you think about it. If you think about these three stages and how we're kind of creating this cycle of taking acoustic sound and physical energy, converting it a few times, playing with it, toying with it, changing it around, or creating it from scratch in the digital world, and then pushing it back out into space, into the air around us. It's pretty amazing. And even right now, while I'm speaking, this process is taking place. I'm talking into a microphone, it's going to a computer, and then being worked on, and then sent back out as a final product and something that you can actually listen to. So you're sitting somewhere, and you can hear me. We've gone through the stage of capture and reproduce. Pretty cool. You're at the end of the chain. Don't feel bad about that, because now you'll know how to make it and be at the beginning of the chain. So there's a lot of changes that go on with capturing and reproducing sound, and the one I want to focus on next is the one between the electrical voltage and going to the digital world, or those numerical values, which is analog to digital conversion. So in the next movie we'll look at that, and we'll look at some of the things that go into making that possible.